हेलो
राजन पीछे क्यों आया?
Come and sit here only. Yeah, at least I'll tell you. I'll keep on telling you what has to be done. Otherwise, you'll not know. Come fast.
अरे
अरे की वीडियो
ऐसा करूँगा।
See, it's better you come here. At least I'll be able to tell you what we are doing. No, you are fine there. I have absolutely no problem. But you don't know what we are doing. That is the problem. What? Come here.
अरे जा
I'm not going to be troubling you. I'll just tell you. Come. Come. And are you Shati have to remind you something? No? You said something that I told you last class. What? You remember? I remember. Ah. That's what I'm saying. Is it available in the shop or no?
not right now.
Not in your school. What do you mean by not in your school?
It is not there.
Why don't you go and check in any of the bookstores? Of course it is there. Okay now. So till here it is okay. Everybody has followed the lesson. It's a comparatively simple lesson because there are not many formulas, not many sums, etc. But there are a lot of questions which are based on experiments. Okay, case studies, experiments, and interpretation of the experiments is what is required. We come to page number 204. We also discussed how basically we are trying to make use of this electromagnetism, not only in different type of appliances, but also in the field of medicine. Okay. Basically, most of you know that there are quite a few gadgets by which you can find out the anatomy of the human body. Okay. So, when we have some kind of an ailment, yeah. And I'll switch it off after some time because it's making noise. It's 2 minutes. Switch it off now. Switch it off. Switch it off. Okay. So we are using X-rays. X-rays can be used only in certain conditions when there is some ailment in the bony structures. Okay, it's a fracture or something. But if there's something wrong in the muscular part, obviously you cannot use an X-ray. That's when we look out for MRI. Have you heard of MRI?
Yes.
Okay. Magnetic resonance imaging. So we are trying to find out what is happening. That's yours or what? Switch it off. Okay. Right? So when we are using the magnetic resonance, we are making use of some kind of movement in the body. Now you know that in the human body, there are different types of ions which are present. Sodium ions, chloride ions, bicarbonate ions. So any charged motion which is taking place obviously causes a magnetic field. But the magnetic field which is caused is very, very, very small. But still we are making use of this magnetic field by amplifying it. So if you actually see the gadget, I don't know whether you people have actually seen in a hospital or in a picture. For example, if a person is having some kind of an ailment in the brain or probably in the heart, okay, so he's fed inside the MRI machine and it's a huge tunnel-like structure, okay. and it has a very strong magnetic field. So what it tries to do is to pick up and amplify the magnetic field which is produced by these charges. And especially these two organs, when you're talking about, let us say, tumor or there's a clot in the brain, that can be very easily detected. Also, if there is any type of an ailment in the heart, that is when it can actually pick up those magnetic fields. Once again, it is fed into the computer, and nowadays the appliances are so well made that you can get a 3D and a color effect, so that the surgeon basically knows how it has to be tackled. So let's look at magnetism in the field of medicine and how we are going to be making use of it. An electric current, that small passage there. Are we there? Which page? An electric current always produces a magnetic field. Is that correct? Okay, flow of electricity, electric current produces a magnetic field. What is your problem now? Wait. I'll do it. Even weak ion currents that travel along the nerve cells in the body produces the magnetic field. What is a nerve cell called? Neuron. From where does it get its impulses? Do you know the structure of a neuron? Yeah? Yeah. So how is it? It's an irregular star-shaped structure with all those thread-like structures. What are those ones? Dendrites and axon. Which is dendrite? Which is axon? So these are the neurons. Okay? And the impulses are brought through these dendrites. Passes through the cyton or the cell body, passes through the axon, and then to the nerve endings. And from here again it passes through another. Okay, so that is how the signals keep on passing. What is this gap called? What is a gap called? Have you heard of synapse? Not yet done?
No.
This is a synapse where it basically contains neurotransmitters. So that's why we call it as an electrochemical impulse. It's not only the electro, but also the chemicals which are present here. Serotonin, okay, acetylcholine, these are the some of the chemicals which are present, which helps to transmit the nervous system, the nervous signals. So here we are talking about the nerve cells. It travels along the nerve cells in our body to produce a magnetic field. Why is it producing a magnetic field? Obviously because it's the electric impulse which is traveling. But this electric impulse is very, very small. You will not even feel it or will not even know it is present. So basically in your MRI machine, what it does is to pick up these impulses, okay, with the help of very strong magnetic field, and therefore it is going to amplify it, and you can see actually what is wrong on the monitor, on the computer monitor. Is that okay, Anjali? Please read. Read slowly so that I want you to pay attention to the words. Yeah, when we touch something,
our nerves carry an electric impulse to the muscles we need to use. This impulse produces a temporary magnetic field. These fields are very weak and are about 1 billion of the Earth's magnetic field. Two main organs in the human body where the magnetic field produced is significant are the heart and the brain. The magnetic field inside the body forms the basis of obtaining the images of different body parts. This is done using a technique called magnetic resonance imaging, MRI. Analysis of these images helps in medical diagnosis. Magnetism has thus got important uses in medicine.
okay, in medicine. Did you underline that the acronym there? MRI, which is resonance imaging. Okay. What is important? Suppose you're asked to write down 1 or 2 lines about it. What is the first word that you need to write? That any electric current will always produce a magnetic field. That is the first line there. Second thing that you need to talk about is, weak ion currents that travel along the nerve cells will produce the magnetic field. That you need to write. Talk about the 2 most important organs, which is the heart and the brain. which produces significant magnetic field inside the organ. Okay. And basically talk about the analysis of the MRI and how it is getting amplified. Is that okay? Just a couple of lines there which will help you to talk about the MRI. Okay, fine. So now that we have done, basically we need to understand that we are making use of different types of devices in order to enhance our life. About 100 years ago, you wouldn't have imagined that we have something which is your Bluetooth technology. But right now we know that it is possible for us to transmit without even wires. Now we are talking about domestic electric circuits. We have done a lot about electric circuits in the previous chapter. So this is nothing but an extension of whatever we are doing right now. So how did we say? Basically, we are having a place where electric current is being produced. So electric current can either be produced due to thermal, okay, or even the hydro or hydral, right? That means by using coal, water, hydrothermal energy. So with the help of these huge transmission lines, it is supplied to the houses. So suppose this is a colony or whatever it is. It can be either to a house or probably even to an industry. Now a particular voltage has to be supplied. What is the domestic voltage which is supplied? What is the voltage here? How much? 220 volts. Okay. So our domestic supply is always 220 volts. Is that okay? But however, for industries, it is much higher, obviously, because the quantity of current which is required is going to be much higher. Now, here when we are talking about a house, there are certain safety devices that are going to be utilized. Now, especially if you are using any of these metallic appliances, let's say you're ironing your clothes or using a domestic, bread toaster or something which has got a metallic body. What happens even if you touch it? Obviously, it is not. You're not going to get an electric shock. So here, what is known as earthing. Now, this is a very important way, especially when a building is getting constructed. You will find that there is a process which is known as earthing. So what they do is dig deep into the earth. It's almost like a narrow well, okay, and they are going to fill it up with charcoal powder and also have something which is nothing but a copper plate. And there's a wire which is leading from here into the building, and this is basically what is known as the earth wire. Is that okay? Did you notice? So even here when you are looking at the socket here, we find here the live, the neutral, and that is the earth. And especially when you look at the plug, you will find that the earth plug, the socket which has got the one, that is slightly larger in diameter. So whatever it is, that part of it will first come in contact with the appliance that we are using right into the earth. So even if there's something wrong with the appliance, the person is not going to get any shock. So earthing is one of the safety devices that we are going to be utilizing. Is that okay? Did you understand? Second thing that we were also talking about is a fuse wire. Where do we use a fuse wire? Why is the fuse wire used? Previous chapter, we have already completed it.
Fuse will basically.
Yes. Yes. Did you realize that? Whenever there is a surge of electric current, where there is something which is known as overloading, what happens is some of the appliances that we are using in our house, like for example a TV or a computer, that can get spoiled. Okay. So what happens is this fuse wire is basically made up of a material which has got a, is it high melting point or is it a low melting point? Fuse wire. Low melting point. It is a low melting point. So if at all you are having excess amount of current which is coming here, this fuse wire will melt. Okay. So the moment it begins to melt, obviously no current will flow home to the other devices, and that is how it is going to be protected. Okay. So remember that the fuse wire always has got a low melting point. Okay. And that's why basically we are making use of different type of alloys which has got a low melting point. So the basic principle here used is which one? It is nothing but the Joule's law of heating. Okay. So even if there is excessive amount of current, heat is generated. Because of the heat, this wire will melt, and therefore the other appliances basically will not have any damage. Is that okay? Right. Also, did you notice that whenever we talk about wires, there are three wires, which is this is only for you to understand. You see that any plug will have the earth, the phase wire or the live wire, and then this the neutral wire. So the potential difference between the phase and the neutral is 220 volts, which is supplied in India. Okay, but the other countries will have different. For example, in the US, it is 110 volts. Okay, that's why we need to have an adapter for it. Okay, have you noticed such a type of equipment at home? What is that?
Switch.
MCB.
Yeah, yes, it's a circuit breaker. So nowadays we no longer use this fuse wire because it is quite outdated. Now this is a miniature circuit breaker. Circuit breaker. That means if there is an excessive surge in the current, basically what happens is it trips over and then it stops the current. Okay, so it is a circuit breaker. Now this diagram of course is not given, so I said okay, let me just show you. What we are interested is in this fuse wire. Did you see this? Did you understand what is happening? You see that is a small fuse wire which is coming in. Have you seen such type of a thing? And this entire thing is made up of a cartridge, which is, yes, basically it will be inside the wall like that. So you can take it out and fix it once again. So what happens to this fuse wire?
Attached to the wall and the fuse cartridge.
Yes. So this is the fuse wire that we were talking about. Is that begins to melt if at all there is an excessive amount of current. Okay. That once again is nothing but a safety device. This is interesting. Now see how they are actually doing the earthing. It's very interesting. Okay. So they are taking a pipe, a tube, and there's a hole which is dug inside. See, like this, right? Into which you're having the tube there. If you especially look at any of the houses or buildings which are under construction, you will find that the first thing that they will do is this. Salt. They fill it up with salt and carbon also. Carbon is nothing but charcoal.
This is that is not a normal solid, right?
Rock salt, yeah. No, there's no need of any refined salt. It's only to give more. That's coal. Pieces of coal.
Why is there a need for coal?
To make the contacts much more efficient. Then of course they're going to fill it up. I just forward it. Once again, layers and layers, we keep on adding. Therefore, making it a better contact. This basically gives you. So that's how the earthing has been made. Okay, what they have not actually shown you is this part. See, now it is the copper wire. And this, if you notice, the earthy color is green wire, right?
Yes, ma'am.
And that is how the connection is made. Just to give you better contact. So where is this wire connected to? It is connected to any of the appliances and the house. Okay, so this is where you will get the other part of the green wire. Okay, so when any building is getting constructed, the first thing that they have to do is to provide earthing. Yeah. You get an idea? Just to show you. Okay, so the earth is also connected. The red one is the live wire and the blue one is the neutral wire. Okay. Let's read this. And how are the appliances connected in our house? Is it in series or is it in parallel? Remember, it is in parallel. Okay, so basically this part of the lesson is going to give you a recap of what we have already done in the previous lesson. Are you having a chiclet? Rules are rules, but I don't break it. Please go outside. Who has the textbook there? Read. Domestic electric circuit. Raj. Domestic.
In our homes, we receive supply of electric power to a main supply, also called mains, either supported through overhead electric poles or by underground cables. One of the wire is this in this supply, usually with red insulation cover, is called live wire or positive. Another wire with black insulation.
Underline the colors. Sometimes a simple question like this is asked. What are the colors? For light,
Red,
for
black,
neutral, and earth.
neutral wire or negative. In our country, the potential difference between the two is 220 volts.
Underline 220. First para.
Second paragraph. At the meter board in the house, these wires pass into an electric meter through a main fuse. To the main switch, they are connected to the line wires in the house. These wires supply electricity to separate circuits within the house. Often, two separate circuits are used. One of 15 amperes current rating for appliances with higher power ratings such as geysers, air coolers, etc. The other circuit is of 5 amperes current rating for bulbs, fans, etc. The earth wire, which has insulation of green color, is usually connected to a metal plate deep in the earth near the house.
What are they talking about now? Metal plate deep under the house. What is it now?
Same as
Earthing. Yeah.
This is used as a safety measure, especially for those appliances that have a metallic body. For example, electric press, toaster, table fan, refrigerator, etc. The metallic body is connected to the wire, which provides a low resistance conducting path for the current.
So is it high resistance or low resistance?
Low.
No, underline. That is very important. And what type of appliances usually have an earth wire?
Refrigerators.
Refrigerator, anything which has got a metallic body. Toaster, okay? Or a refrigerator. So such type of appliances have an earth as a safety measure.
Thus, it ensures that any leakage of current to the metallic body of the appliance keep its potential to that of the earth, and the user may not get severe electric shock.
Okay. Why do we have 15 amp and 5 amp? They've already
We have
mentioned it.
for high rated appliances like AC, fridge,
Very good.
air
Okay. And
coolers.
when do we use a 5 amp current? Yes, for bulbs.
Low ratings.
Or low. So, in fact, there are two types of lines which are coming in, right? Some of them are for the higher appliances, rating which has got a higher power, and some of them, of course, are for the lower ratings. Okay, very good. So, there's a diagram here. I want everybody to observe it for 2 minutes. I'm going to ask you questions. See how the wiring is provided. Did you all see that?
Raj.
What are you seeing? What are you seeing? Diagram, yeah. Which one? Those three things. That's. Did you notice the three colors?
Yes, ma'am.
There's a green line. What is a green line?
Power.
Is it clubbed along with the live and neutral? No.
Separate.
It's a separate one because it's separated and it is kept away and it is providing the earth connection. Okay. What is the potential difference between live and neutral? What is the potential difference between live and neutral? Well, Ken, you have read it now.
220.
Correct, it's 220 volts. Okay? Okay, so how are the appliances connected? Did you notice? Is it series? Is it series? It's never in series. We have discussed so much. It has to be in parallel. Write it there. Next to the diagram, you write down.
Is in series.
Parallel. How does electricity first come into our house? Does it directly come? Yes, it comes through an electricity board fuse. Then it comes to the electricity meter. Why does it come to the meter? Very good. Yeah. So it depends upon our usage. Voice. Electricity meter. There's a meter there which tells you how much you have used. Okay. And then of course it comes into the distribution box. Here of course they have not told you anything regarding the fuse wire. But fuse wire is always connected in series. Remember that. Okay. Read the next part. Till there you have read. Anybody from this side? Read. Who wants to read?
Manish.
Right now. Popular demand. Eh? I know. Sir.
Figure 15. Yes.
Of course he said 15.
Diagram of one of the common domestic circuits. In such separate circuit, different appliances can be connected across the live and neutral wires. Each appliance has a separate switch to on and off. The flow of current through it, in order that each appliance has equal potential difference, they are connected parallel to each other.
Underline. They are connected parallel to each other. What is the advantage of having parallel? Such that it has got the same potential difference.
Electric fuse is an important component of all domestic circuits. We have already studied the principle and working of a fuse in the previous chapter. A fuse in a circuit prevents damage to the appliances and circuit due to overload.
Underline the word overloading. Now overloading can happen due to many of the other causes. Okay. So let's see what is basically when there's an excessive surge. Okay. When there's an excessive difference in the voltage, sometimes there's a surge of electricity and then it can cause overloading. Sometimes also you'll find that there are too many high power gadgets which are running together. Somebody has switched on an oven and the freezers and the AC, everything is on. Then also it can cause an excessive surge of current and that can also cause overloading. Another thing is most of the cases you would have seen that a small electric spark can actually bring about. Anish, now I should find out.
Ma'am, I'm
You are telling, come here.
ma'am.
Harika,
Go.
I'll give you a chance to talk. Okay. So now, when we are talking about the live and the neutral wires, we always make sure that it has got a plastic coating. It's not plastic, it is a PVC coating. What is PVC?
Poly
PVC,
polymer.
vinyl chloride. What is it? It's polyvinyl chloride. Okay. So basically that acts as an insulation. But sometimes what happens if the building is very old, so the PVC covering on this, okay, can get worn out. And if these two wires are in contact with each other, that is when it can cause an electric spark. And one electric spark can set the whole building.
Also, pipes are not made up of plastic.
Yes, PVC plastics for making hose, PVC chappals are also there. So PVC is nothing but a polymer. Okay, it's an
So they are a
insulator.
mix of chemicals and petroleum.
Which one?
Plastic is made up of petroleum, right? Some part.
Plastic is nothing but a polymer which is made up of different type of monomers. Okay, we read a little more about it when we do carbon and carbon compounds. Basic material, of course, is from petroleum. That's it. Is that okay? Yes. So what causes sparking? Sparking is happening whenever there is a contact between the live and the neutral, for which the PVC has actually getting worn out. Okay? Especially in the rainy season, we find that sometimes if there's water leaking on the walls, okay, it can also cause a mild amount of electric shock. So that's also because the wiring has lost its outer PVC covering, and that will bring about shocks. Okay, come on, continue.
Overloading can occur when the live wire and the neutral wire come into direct contact.
Underline. They come in direct contact with each other. What are the two wires that we're talking about?
Neutral and live.
Yes, never the earth. It's always the live and the neutral.
This occurs when the insulation of wires is damaged or this is a fault in the appliance. In such a situation, the current in the circuit abruptly decreases. This is called short circuit. The,
Underline the word short circuit. Yeah.
the use of an electric fuse prevents the electric circuit and the appliance from a possible damage by stopping the flow of under, un,
Unduly.
high electric current. The joule heating that takes place in the
Underline.
fuse
It is because of the heating effect or the joule heating.
make metals to break the electric circuit. Overloading can also occur due to an accidental hike in the supply voltage, sometimes
Okay. Wait. Underline that increase in supply voltage. So what happens if there is an increase in the supply voltage? Voltage is increasing, there's an excessive amount of current. Last point.
sometimes overloading is caused by connecting too many appliances to a single socket. Khatam.
Last one.
Easy to understand what we have.
Anything else? Any doubt? Is it okay? Last part of it. It's nothing but general information regarding what are the safety devices and what you can do about it. Okay. Go to this page. Or I'm read from here. The last two bullet points. We have to read
Last two.
in our houses.
In our houses, we receive AC electric power of 220 volts.
Underline 220 volts.
With a frequency of 50 hertz. One of the wires in this supply is with red insulation called live wire. The other one of black insulation, which is a neutral wire. The potential difference between the 220 volt, the potential difference between the 220 is 220 volt.
The third is the earth wire that has brief insulation and that this is connected to a metallic body deep inside the earth. Deep inside Earth. It is used as a safety measure to ensure that any leakage of current to a metallic body does not give any serious shock to a user. Fuse is the most important safety device used for protecting the circuit due to short circuiting or overloading of circuits.
Is that okay? So the last 2 points are basically related to the submission. Is that okay? Come on, write down a few points. Question number 9. We have question 9. What is the function of the earth wire? And why is it necessary to connect the earth wire to a metallic body?
What is the function? Other than the nine question number 9. Safety check that
You should be able to write. Someone write down.
That any leakage of current to a metallic body does not give any seepage shock.
Yes, someone write it down. All of you will write it down. Afterwards, we will discuss if there are any additional points that you need to write. Right? What is the function of the earth wire? Page number 167 here for you. Arush, write down the answer. You can refer to your textbook and write. Okay. Read out your answer. Earth wire.
Earth wire is a safety measure to ensure that any leakage of current to the metallic body of the appliances keeps it essential to that of the earth and user maintenance.
Okay. But what is the color of the earth wire?
Green.
Yeah, you can write the color of the earth wire also. It's green. How is it connected? It's connected to a copper plate buried deep inside. Write on that also. The earth wire is connected to a copper plate buried in the ground, deep under the ground. Have you written it? Okay. Done? Let's see whether you've got all the points. Raj, what have you written, Rita?
The green wire or the earth wire is used as a safety measure to ensure that any leakage of current to a metallic body does not give any seepage shock to it.
Okay, but it is attached to what?
Metallic body.
See, एक तो है तुम्हारा green wire. One part of it is attached to the metallic body. The other part is attached to where?
No.
To another copper plate which is kept inside the earth. That's correct. the other end of the copper wire of the
Then
Okay, next question. I'm asking you to write down the colors of all the three wires. You know what are three colors?
yes,
Red,
red.
So write colors on one side and on the other side what it is representing. Write it in the form of a table.
but color and function.
Yes. Color and what it is. What does it represent?
Just time I write it one because
This
Just the color of the
one
wire.
color. Yeah. And what it represents. Red is representing what?
Live
Live
wire.
wire,
Live wire.
black is
Yellow
representing
live
neutral
wire.
and
Green is
earth.
Yes. Karan, leave your book there. Go. Go. You know very well. Go. Go. Find something in your mouth.
I heard Socha.
Sure.
Yes.
Drink water now. Finish?
Yes.
Finish, all of you? Okay, next one is a fill in the blank. Go to the colors. I'm telling you. The next is a fill in the blank. I'm telling you a sentence, you have to write down certain words inside. Take down this. In our houses, we receive AC electric power of dash voltage with a frequency of dash 50 hertz. Good. 220 volt and 80 hertz. Hertz is usually a unit of the frequency.
Frequency of the
Okay. Next one. Okay.
Yes.
Why is a fuse wire? Why is a fuse wire essential in domestic circuits? क्या लिखोगे?
Is used for protecting the
Safety
circuits,
device, right?
So this one is
circuits in
circuiting
the
and
source,
the
overloading of the circuits.
Okay, very good. Based on what? What is the principle for the fuse wire? Melting point बोलो. High or low? Low. Low melting point, so that it melts very fast. What else? Low melting point. It is based on Joule's law of heating. Okay, so if there is an excessive amount of current It gets heated up and it should get. Correct? All the points are here. Come on, write down. 3, 4 points are here. Here also you can, with the first point you can pick up from here. Use is the most important. Use the of heating. Fuse is the most important safety device. Used for protecting devices from short circuit or overload.
They are protecting the circuits.
Circuit their device will keep it. Okay, second one.
It is based on the units.
Based on
Sodium module.
that is also there. You never get the problem. When did I see that? Bio is there. So always you get problems. Afterwards we can. Say next point, what are you doing? It is based on Joule's law of heating and work. Based on Joule's law of heating. Third point.
And it has a low melting. And if you do that, it's a low melting.
Yes, very important. Fuse wire is made up of an alloy which has a low melting point. This is given in the previous chapter. Fuse wire. Fuse wire.
Joule's wire.
But Eva has high rating.
Not all of us. Some others also have, especially lead and tin. Silicon alloy with lead and tin. It's obvious. Parthiya, okay? How is it? Where is it? Is it in series or is it in parallel?
It's always
Series.
Fuse is always in series, right there. Okay? Next question, I'm giving you the next questions. Okay, what is overloading? Next one. Once again here, overloading. One minute, Ananya, please.
overloading can occur when the light wire and the neutral wire come into the wire.
Okay?
This occurs when the insulation of wires is damaged or there is a fault in the appliance.
Okay?
In such a situation, the current in the circuit abruptly increases. This is called a short circuit.
Okay? What else?
The use of
No. Last line. Overloading can also.
overloading can also occur due to an accidental hike in the supply voltage. Sometimes overloading is caused by connecting too many appliances to a single point.
What are the points? Come on, write down. I don't want about fuse, only about overloading. It's not given there.
Just checking the fixed part, then I get.
I've already discussed 4 points, no? What all have you written? Fuse you have not written?
No, I don't fuse.
Come on, the next is overloading. Finished? So fast. Last line also you written. Wait.
Overloading can occur when the live wire and the neutral wires come into direct contact. Overloading can also occur due to accidental lightning supply.
Okay.
Um,
Yes. Yeah. An additional point that you can add there, please.
Overloading can occur when a live wire comes in direct contact with the neutral wire. When the insulation of the wires is damaged or
Yes. The reason for it also you should write when the insulation is getting damaged.
there is fault in the appliance. Sometimes it is caused by connecting too many appliances to the same socket.
You have written.
But also fuse in a circuit prevents damage to the appliance and the circuit due to overloading. Then
Okay, there's one fill in the blank here in your volume. Electric fuse and switch are connected with dash wire. One of
One page.
here on 176. If you are having your volume, page number 176. Domestic electric circuit. See the 17th and 18th one. Now Raj is reading the 17th one.
dash are used in electric fans, electric blenders, electric washing machines.
Right. And
18th one. The force experienced by a current
क्या है
can
इसका आंसर तो पता 17th का क्या है? What are used in all these? What is common? Grinder, motor, fan, what is it? Electric motor. Basically, we are using the motor. So this is the motor jal gaya. So it's obviously a motor which is bringing about this.
Electric motor, ma'am.
Oh,
Correct. Next one. Breathe.
The force experienced by a current carrying conductor in a magnetic field is the maximum when the direction of current is dashed. The direction of magnetic field is perpendicular.
हो गया 17 18 is also over. क्या है आंसर क्या है?
Perpendicular.
I was asking him. He didn't know. हो गया? बताओ और कुछ है?
19 and 20 are
Also there, but some of them are all for DC, AC and all that. Okay, read the 19th one. It is interesting. 19. That's one.
A current carrying conductor experiences no force in a magnetic field if the direction of current is dashed. The direction of opposite man.
When is it experiencing maximum force?
Opposite.
When it is perpendicular. Okay. When does it experience no force? Where it is in the same direction.
How can it be the same direction?
If suppose this is the north and the south pole, and the direction of the current is also in the same direction, then you cannot experience it. Okay, the last one.
The resistance of a high power electrical appliance is dashed than that of a low power.
The resistance of the
The resistance of a high power electrical appliance is dashed than that of a low power.
yes. Okay, now write down this question. There's an index question. 205.
Question number 1.
First one. I'm not going to discuss this answer. This is a very detailed type of question, right? And then afterwards we will talk. Just write only 2-3 points.
too simple.
Circuit and appliance. What do you say? No. Now they're talking about an electric circuit mechanics. Appliance में तो और होगा ना?
Okay.
Tomorrow is also a class.
Wednesday and Thursday. Same time? Is it the same time?
Same time.
Tomorrow we'll start a new chapter. Tomorrow we have already completed a new chapter.
Just science.
Mom, and when the whole portion will be completed.
Physics whole portion is completed.
Yeah, 4 chapters. Yeah. And plus we are having 3 periods. Big periods, these are 3 periods. So each, for example, that electric circuit also takes 10 hours. Late our period. So the 3 periods, 3 hours, so you are not doing that. Otherwise it would have gone for 3-4 months. But because all the public are having different portions, no?
अच्छा हाथ पे गुड गुड it is written now like कल SST नहीं है कल maths सर maths है कल मैं स्कूल जा रहा हूँ
Actually, please put that thing inside. No need to check. Everybody knows. Harush. Okay, finish this. Did you complete? What did you write?
The fuse and wire.
Fuse
What?
Ma'am, each circuit must be
I want you to do the second one here. Second one is a problem. Come on, do it.
Second one. Inter 2000 watt. Instead of 2 kilowatt.
मैसेज चालू है हाँ
Short circuit.
Yeah. Twice. Garam, how will you do this now? What is that? Current. Why? Why? Means what? What are you doing?
Current is less but the power is power and
Which formula did you use? Very good. Very good. And if you don't get the answer, let the others think and do. He's already done it. R is equal. Now first write down what is given to us, then you'll understand. What is given, write it down. What you have to find, you have to write. Which formula you are using. Yes. P is given in kilowatt. Convert it into watt. 2000 watts.
What do they have to find?
You have to find.
What they have to find?
That is what. First you read. Correct. What is given? P power is given. Volt is given. 2000 upon current is 1. 5A is the fuse. Rating of the fuse. So you have to find out I first. First you find out I. And then you compare it with the fuse rating.
9.79 नहीं मैम गलत किया सॉरी
Live, basically it isn't live.
हाँ मैम 9.09
What did you find?
मैम I सही सही
क्या हुआ था?
There are some.
What is that?
हम तो भी अपनी यूज होते हैं
अभी I have क्या?
नहीं
Okay. This is what is given. Okay. Power is given. Power is given. Voltage is given. So use this. You have to find out first I. P is equal to V into I. I you will find out by using P divided by V.
Current is given.
Now read that carefully. They are talking 5 amp is the rating on the fuse. Okay. So now they are asking you what happens. What do you think will happen to the fuse wire?
9.21 exceeds the limit.
Yes.
So it will melt.
Very good. It will melt because it's taking in 9.09 I, so much of current. So this fuse wire will whatever 9 point whatever you have got. So your fuse wire is about only 5 amp rating. So if 9 amps of current is flowing, it will melt obviously. So what type of fuse are you going to use here? What type of fuse should you use here? You can't use 5 amp. So what? 10 amp. So you have to use a 10 amp. Most right.
I'm getting sleepy now, so I will.
I want to submit. Not come.
अबे वाटर लेके जा रहा हूँ
Yeah, water. Why is it नल का पानी को बराबर देख आरुष. So I will do this to this but I will do
अरे मेरे को
So yeah, इसको देखा
what do you think the unit?
I use half pound. And the question is why? What will happen? It will melt. Okay. Shall we go to page number 174? Page 174, and we'll do the worksheet which is there. Yeah. Fill in the blanks. Worksheet, fill in the blanks. Everybody has it.
Yes.
Try to fill in as many as you can. Look at it. Write down as much as you can, and then you are going to
Mom, your answer is current, right?
I am asking for a volume. I don't have a book right.
Current and
Try to fill in as much as possible.
You see, you are in like नीचे
Mom, but current
First roll of flag.
of south and north.
Voice. Gaurav, come here. We are not wasting time, please. Once we finish this, I'm going to give you some other extra questions of the previous chapter. Don't waste time. We still have got good 15 minutes now. Don't waste any time. Sit there. Do your work silently. Sit here.
This madam right hand.
Write some.
Wait, let me see the question. I've asked you. Magnetically.
And right hand thumb rule is also Fleming.
Depends upon the direction.
So magnet में correct. Correct and magnet use.
Okay. Class. There's one thing. Here. In the previous textbook, we had something about, are you all listening? Yeah. AC and DC current. It's not here. But sometimes in some of the question papers, they might ask. So have a look at this part. This is pretty good. Just to give you an idea regarding DC current and AC current. Basically telling you, shall I explain this? Shh. Look here. We are talking about the flow of charges. Okay, now we said that the flow of charges are nothing but the electrons. So the conventional energy considers the flow of positive charges. Okay, so let's see from here. Ananya, just wait.
This is an example of direct current. Here we have a cell or a battery in a circuit. The current in a cell only flows in one direction, so the electrons only flow in one direction around the circuit. But be aware that by convention, Current is a flow of positive charges, which is what you see here. The electrons which actually form the current are negatively charged, so they flow in the
I'm
other
not playing this
direction.
again, and it's not there in the
In
textbook.
this example, instead of a cell or battery, we have a mains power supply. The mains supply is an alternating current, or
AC
AC,
current is always
which
shown by
means
this
the
sign.
current constantly changes
Okay, so that's
direction.
your sinusoidal sign. Whereas
The
the
number
battery
of
gives you a
times per
DC
second
current.
the AC changes direction is known as the frequency, which is measured in hertz or cycles per second.
What's the frequency?
The frequency of
hertz.
alternating currents is different in different parts of the world.
See?
So why is our main supply an alternating current? The main reason is because it's much easier to use a transformer to change the voltage of AC than DC.
So when we talk about
Transformers are used in lots of appliances to ensure that they have the correct voltage to work. Transformers are also an important part of the national grid, allowing electricity to travel along wires and cables efficiently. For more on the national grid, watch this video.
do you understand? So we have got what is known as a
We
step-up
can see on
transformer,
this
step-down
oscilloscope the
transformer.
voltage or potential difference constantly changing from positive to negative, and so driving the current in alternate directions. An oscilloscope trace for direct current would look like this.
DC
There
is a
is no
straight line.
change in voltage, so
Okay,
the
and
current
AC
is
current has
also
got a
constant.
sinusoidal mode.
So what about this oscilloscope trace?
Direct
Is
current.
it AC or DC? What's the maximum potential
Alternating.
difference? What's the frequency? Pause the video for a moment to work it out.
AC.
Alternating.
The trace is AC. We know this because the potential difference increases and decreases. The maximum potential difference is 200 volts. The frequency is the number of times the voltage changes in 1 second. We can see the distance between the two pleats on the graph is 1 complete cycle. This time is 0.02 seconds. That's the time it takes for the current to change direction and then back again. We can calculate the frequency like this. 1 cycle takes 0.02 seconds, so 5 cycles take 0.1 seconds, which means 50 cycles in 1 second, or 50 hertz. So those are the differences and uses of AC and DC, and how we can interpret oscilloscope traces of current.
That's an oscilloscope. Okay, basically helping you to understand what is a DC and an AC current. Okay, what is DC? It's a direct current which is supplied by a cell, whereas an AC current is the one which is supplied by the main. So that is usually a sinusoidal wave. Okay, because the frequency changes. So when we say it is 50 hertz, it shows that it is 50 cycles per 1 second. Did you understand? It's not given here, but sometimes some of the questions might be included. So at least this part of it you must remember. Okay? So, where are we now? The worksheet part of it is over. More of talking and less of writing. No talking and more writing. That's what I want. Quick, quick, quick.
In this module, principle of electromagnetic induction. It now knows which moving the galvanoid will be moves down at this position first by rotation.
I think I'll ask you to write it in your notebook. Come on, I'll dictate. All of you take it down. Yeah, someone write down. And we have selected few You will be writing in your notebook and filling the blanks. I'll not give you everything, okay?
You can be right.
I have no option. Come on. The magnetic field. Why am I screaming ahead of you? Right. Arush, in your notebook, Arush, write a full statement. The magnetic field. Hello, right? Yeah. Write it in your notebook. In your notebook.
We have volume shooting.
I have volume. I also have a volume of articulate from somebody. There's so much of talking now. Chalo then, let's see. Pass. Where are you starting? Leave that, whatever you're studying, just go on to the next one. Okay? What you know for sure is that
Cylindrical wire or metallic wire is called.
the strength of the magnetic field is increasing the number of turns. Reducing the software
Acts like a bar magnet and there is current.
soft iron core. Core, COR. Like what I have used an iron nail to bind.
We are referring to
Which one? What you don't know even about it. We'll discuss later. What you don't know, you leave it out. Fill up the ones that yeah.
हम लोग को वहाँ से दिख रहा है कॉल आ रहा है
all this all disconnect.
Yeah, Ayush. Textbook, notebook. Otherwise, call to your parents.
Third option.
This is your notebook.
Yes.
इसके अंदर भी जाएगा ना
Very sad to hear.
Bye.
चल देखो क्या
नीचे जो आता है कार्ड ये तो पता ही था ऑब्वियस नहीं था
ऑब्वियस है भाई, तो वो तो